Number 20, which is the most polar bond? And then we have A through E. So this would kind of be like a multiple choice question. So we got to figure out which one out of these 5 would be the most polar. The bond would be the most polar. And that comes from finding out the electronegativity, En, difference. Now, a couple of things is that difference, whenever you find a difference of something, you're always subtracting, right? And just know that your electronegativity difference should always be a positive number. So in order to get that, it doesn't matter which atom is where, meaning whether the carbon is to the left or the hydrogen is to the right. In order to get the positive number, you should just subtract the higher electronegative number minus the lower electronegative number in order to get the positive. Now, if you do it the opposite way, just know that your answer should always be the absolute value. So you should just look at the negative number and say, oh, okay, it should be the positive answer for that. All right? But that's all we're going to do. We're going to find the electronegativities for each one of these atoms, subtract them, and see which one has the highest difference. The highest electronegativity difference, in this case, would be the most polar bond. All right? So, let's go for it. A. We have a C-C bond. They're exactly the same. So, carbon, which is over here, has an electronegativity of 2.5. So if they're both 2.5, there's really no higher or lower. So when I subtract the 2, I will get 0 as my electronegativity difference. So I'm just going to hold that one there. So I'm just going to put that this electronegativity difference would be 0. For B, let's find the electronegativity difference. We have a C bound to an H. So the carbon we already know is 2.5. The hydrogen, which is over here, is 2.1. So if I subtract them, you would get 0.4 as your electronegativity difference. So right off the bat, this bond, a carbon to hydrogen bond, is more polar than A. So we could automatically eliminate A as one of the answers. So A's out. Now let's move down to C. C is an NH bond. Well, nitrogen is 3.0 electronegativity, and hydrogen, like we said before, was 2.1. So if we subtract them, we now get a 0.9 electronegativity difference. The higher the number, the more polar the bond. So this bond between nitrogen and hydrogen would be more polar than this bond between carbon and hydrogen. So B's out. And now we're down to C being the answer, maybe. Now let's do D. I'll put D over here. D is an oxygen-hydrogen bond. Well, we know hydrogen from before, that's 2.1, and we're going to subtract it. Oxygen is right here. It's 3.5. So when you do 3.5 minus 2.1, you get 1.4. So we're getting even higher number between the electronegativity difference. 1.4. So that means that this bond has a higher electronegativity difference than this one, which means that this one, the OH, would be more polar. So C's out. And then finally, let's do E. So C's done, and I can fit E over here. Selenium bound to hydrogen. Hydrogen we know is 2.1. Selenium is over here, which is 2.4. So when we subtract the 2, 2.4 minus 2.1 is 0.3, and now we've gotten a little bit lower. So between these two, the OH bond would be the higher one as opposed to this one. So this bond, the OH bond, would be the most polar bond. E is not it. So that's it. So the higher electronegativity difference, the more polar the bond. So that's why D is the answer. And that's that. All right? So this one's checked off. We're all good for that one. Hope this one helped. If it did, click the like button just to see if I'm in the right ballpark as to getting to you guys the most efficient way for you to understand. Click subscribe if you want to. I hope you guys have an awesome day. I'll see you guys in the next question. Bye-bye.